Hello guys, today's LeetCode problem is minimum falling path sum. Okay, and this is again another recursive problem and DP problem here. And let us dive into the problem very fast. And so, given an array of integers matrix. So here it is a matrix now. It is not an array, and we have to return the minimum sum of any falling path through the matrix. So what is falling path here of a matrix? Let us visualize the falling path here. Okay, A falling a falling path starts at an element in the first row. So it always starts in the first row of any element. Okay, it can either start here or can either start here or can it either start here. Okay, and chooses the element in the next row. So and it goes on choosing the elements in the next rows. Okay, and next row that is either directly below. It can choose here or it can choose here. This element. If we consider this element, then it can choose this element, this element, or else it can choose this element, especially the next element from position. So if the position of this element is chosen in the first row, then it can choose the next element in the next row as this element or this element or this element. Okay, so the falling path can be in this way, right? So it can choose the elements. So it has to be started with the elements in the first row, and it can choose the elements in the following way. In the diagonally left, it can choose. In the below straight, it can choose. On diagonally right, it can choose. Okay. So for example, the falling path can be in this way, right? In this way, it can be the falling paths can. Be. So among all these falling paths, we have to choose the minimum sum of any falling path. Okay, so we have to choose a minimum sum falling path here. When we go keep on adding these values, we get the sum, right? We have to choose that sum as a minimum, right? Okay, so let us quickly uh, do the recursive try to code the recursive solution of it, so we get an visualization here. Okay, so if you observe here one thing, we have to observe for the text edge cases, right? So if you observe one thing here, so if the chosen element is like if it is 0, then it cannot choose the left element, right? So if you carefully observe, if the position of an element, if the row position of an element is 0, okay, when can an element choose its left element? Whenever it is greater than 0, right? So if it is greater than 0, then it can choose the left element, right? So if it is here, the position of the left element position of an element is greater than 0, then it can choose the left element, right? So for example, this indexes are 0 comma 0, right? The row index is 0, so it is equal to 0, so it cannot choose the left element, right? So this is the base condition one, so we have to consider this condition. Okay, and so here let us come here, and this is 0 comma 1. So here the column index is 1, right? So it can choose left index, right? So it can choose left element because the column index is greater than 0, right? So if the column index is greater than 0, then it can choose left element. Okay, so for choosing right element, what should be the column index? It should be lesser than n minus 1, right? So if the length of the column is 3, then it should own the element index should be lesser than n minus 1. That is n minus 1 means if the length is 3, then it should be lesser than 2. So that is 0 and 1 it can choose, right? From 0 and 1 it can choose left element, right? Right element, right? So if the element is here, then it cannot choose the right element, right? Because it is out of bound condition. So we have to take care of these conditions. Okay, so let us quickly do the recursive approach. So, and one more observation here, one more edge case. So whenever you come to a row, whenever you come to the last row, you cannot choose any element. See, you cannot choose any element from here. You have to go downwards, right? So you cannot choose any element from here. So this would be our base condition. If at all our rows position is equal to n minus 1, then we have to directly return the value of whatever the value here, we have to return it. Okay, in the recursive function. Okay, so this is our base condition, and these are the conditions we have to handle. Okay, so let us quickly dive into the solution. Okay, So first of all, what he said is we have to find the minimum path, right? By choosing any element from the first row as a first element, right? We have to choose first element from we have to choose first element from the row one only, right? We have to choose it from we have to start it from row one only. So let us take we have to find the minimum. So let us take the minimum value and okay, and we have to um, as we have to consider only elements in the first row as starting element, right? So we have I will iterate over the first row and I will keep on I'll iterate over first row and I will keep on choosing the first elements in the first row, okay, as a starting element, okay. Equal to 0, I less than n is a let us initialize n value here. Int n is equals to matrix dot length, okay, and let us and I plus plus, okay. And so now we have to find the minimum, right? So math dot min of min comma we have to call a function which returns an integer. So this will be the minimum sum, right? Sum along the path here, okay. So we have to call that function. So what will be the elements starting index? It will be 0 and the column index will be I, right? Okay, and we have to pass the matrix and we have to pass the array, okay. So now let us at last we need to return minimum here, okay. Let us try to do this solution here, try to solve the recursive solution of solve function. And what are the parameters here? Int I comma int j and int mat, right? And one more variable is int n, okay. So now what is our base condition? So if I is equal to n minus 1, then we need to return urn return mat of I comma j, right? So whenever we are at a we are at the last row, then we have to directly return the element, right? So and one more condition what we have to check, if and we have to consider left, okay. Integer dot max value and int right, okay. Integer dot max value. So what are the ways we can go? Left, straight, and right, right? So we have considered two variables, left and right. Okay, for left and right only there are conditions, right? We have to consider. For straight condition there is no condition, right? We have to consider it. So for straight condition we can directly solve it, right? So we have to consider the left and right. So if j is greater than 0, if j is greater than 0, so j can uh, j is greater than 0 means the column index, right? The column index of an element, if it is greater than 0, then only we can consider left, right? So greater than 0 means if it is 1 or 2 something not equal to 0, right? So whenever the element is in this way, not in the 0th position, this is the 0th position, this is the first position, and this is the third position, right? In the column wise, this is the row wise, right? This is 0 index, this is 1 index, and this is second index in the column in the row wise. So whenever it is in this box, then only we can consider the left by we can go to the left, right? So left equal to what will be left? You have to call the function solve I plus 1. We need to go diagonally left, right? So row will be increased and j will be decreased, right? And we have to call the mat function and n, okay, when we pass this thing, okay. Now if j is lesser than n minus 1, then only we can consider right, then only we can consider right. Solve I plus 1 j plus 1, right? Mat comma n, that's it. And what will be the state condition? Int state will be there is no need of checking that, right? So I plus 1 and j, right? So from here to go here, we have to increase our row and we have to keep the column as same. And now at last we need to return the math.min of left, comma math.min of right, comma straight. And we need to add the value here. What is the current value? We need to add that thing. Okay, this is a sum, right? For sum we need to add our current element, right? So we need to add this thing. So let us quickly run this problem and let us see the output here. So it will pass for the first two test cases. So it is cannot find symbol. Okay, okay, I think here I have written underscore. So it has passed the solution, right? So our recursive approach is perfect. So we need to convert this recursive approach into a, so however, if you check the constants here, they are 100 and we are using three ways to travel over c, so it will be 3 to the power of 10 100, and it is an exponential, so it is the time complexity here will be so long. So we have to decrease the time complexity, right? So for decreasing the time complexity we need to optimize the solution. What is the optimization of the recursive solution? The DP approach, right? So we will try to solve this in a DP approach. For solving the DP approach, first let us visualize the let us visualize the recursive tree, right? Here will let us visualize the recursive tree here. Okay, so let us visualize the recursive tree here. Okay, and if we zoom it little bit, so I have three choices, right? Whether I can start my element from 0 comma 0, or else I can start my element from 0 comma 1, or else I can start my element from 0 comma 2, right? So what if I what if what if I start my element from 0 comma 0? Okay, that is two element, right? So wherever I can where I can go here, like I can go to the left if it is greater than 0. So is j is greater than 0, j is not greater than 0, so cannot go there. So this will return max here. Okay, so the left will be max here, right? So it is max. Okay, where I can go next? I can go straight, right? uh, I can go straight, or else I can go right. Okay, I can go right, right? So is j is lesser than n minus 1? J is lesser than n minus 1, so I can go right here. So I'll go right here. Okay, so let us increase this font, and let us bring this closer. And okay, now it is visible, right? So I will go to the right. I will come here. I will come to the left, fifth place. Now I will try to call the solve function for I plus 1 and j plus 1 here. I will try to call the from here where I can go. From here where I can go. So I need to check here again. So is I is equals to n minus 1? Is I is not equal to n minus 1, because I is equal to 1 and n minus 1 is 2, right? So I is not equal to n minus 1. So we'll try to solve the approach here. Can I go to left? When can I go to left? If my j is greater than 0. Is great j is greater than 0? Yes, it is j is greater than 0. So I will go to left here. So I'll go to left. I'll come here. I'll come here. Now, after coming here, I will check whether it is equal to n minus 1. Yes, and I is equal to n minus 1. So I'll directly return my answer here. Okay, I'll just return the value here. So it will be 7. I have written this. So from here, where I can go? Shall I go to right? Yes, I can go. Shall I go to right? Yes. J is lesser than n minus 1. Yes. 1 is lesser than 2. So I can go right. So I'll go right. And from here, I'll go 9. I'll go to 9 here. So, so if you observe here, one base condition is satisfied here. I is equal to n minus 1, so 2 is equal to 2, so I'll directly return the value here. I'll return 9 here. So from here, I have written 9, so I will return 9 here. So where I can go, I'll go to straight here. So from straight, uh, I will call for the function for straight here. I'll go to, from 5 I will go to 8. So if you observe here, 8 is in the last row, so it is a base condition, so it will directly return the value here. So I have returned the value. So now what I should do? So I have got the all the values for the left, right, and straight, right? So what I should do here, you have to find the minimum here. So what is the left? 7. And what is the straight? 8. And what is the right? It is 9. 7 comma 8 comma 9, what is the minimum here? 7. And we have find the 7, and what you have to return? 7 plus 5. So I will return 12 here. Okay, so I will from right I got 12. Okay, from left I got max. From here, okay, from here I got the left index as max, and from the right index I got 12. I'll check for the straight index now. I'll go to straight. Okay, I will go to 6 here. Okay, so from 6, where I can go? Can I go to left? Is j is greater than 0? No, j is equal to 0, so I will return max here. So can I go to right? Is j is lesser than n minus 1? Yes, it is lesser than n minus 1. So I'll go to here, and if you come here, it will be the base condition I is equal to n minus 1, so I'll return 8 here. So can I go to straight? From 6 can I go to 7? Yes, I can go to 7. So it is a base condition, so I'll return 7 here. So what is the minimum value from these three, from left, straight, and right? So 7 is the minimum value, right? So I found the minimum value, plus what I should return? I should return the value here. From this I should return. So 7 plus 6 will be 13. So I have written the 13 here. Okay, so from right I got 12, from left I got max, and from straight I got 13 here. What is the minimum here? 12. 12 will be the minimum, and plus what is the value? 2. So I will return 14 here. Okay, so from, if I consider the element as 2 from the first row, then I will get as 14 here. Okay, so what if I consider the element as 1 from the first row? So if I consider first, so what if I consider the element, the the second element from the first row? Okay, so it will check if I go, can I go to left? Is j is lesser than 0? Yes, it is lesser than 0, so it can go to left. So it will go to 6 here. From 6 it can go to left? No, it can't go to left, right? Because the j is lesser, j is equal to 0 here, so it can't go to right. So it can go to right, so it will go to right, and it is a base condition, so it will return 8. So it will go to straight. From here, from here it will go to below straight. Okay, it is a base condition, so it will return 7. So from max, 7 and 8, what is the minimum? 7 is the minimum. So 7 is the minimum, and what is the value here? So 7 is the minimum. 7 plus, what is the value here? It is 6. 7 plus 6 is 13, so it will return 13 here. Okay, so from going to left I got 13 here. Okay, now what if I go to right, straight here? Okay, if I go to straight, what is the minimum value? uh, from straight, is from straight, from 5, can I go to left? Yes, I can go to left, uh, because j is greater than 0, here 1 is greater than 0, so I'll go to left, and it is a base condition, so I'll return 7 here. And can I go to straight? Yes, I can go to straight, because it is also it is also a base condition here. 2 is equal to 2, so I'll return 8 here. So can I go to right? Okay, from up for 9, if I go to 9, so it is also a base condition, so I'll return 9 here. Okay, so what is the minimum value of among these three? So 7 is the minimum. So 7 plus, what is the value here? 7 plus 5. 7 plus 5 is 12. Okay, so from, if I go to straight, I will get a value as 12 here. Okay, So what if I go to right here from 1? Can I go to right? Yes, I can go to right. So from right, from 4, can I go to left? Yes, I can go to left because j is greater than 0. So it is a base condition, so it will return 8. So can I go to straight? Yes, I can go to straight. So it is a 9 and it is also a base condition, so it will return the value here. Okay, so 9 will be returned here. So can I go to right? No, I can't go to right. So I'll return max here. So among these three, what is the minimum value? 8 is the minimum value. So from 8, I got 8 as the minimum value. And from here, what I should return? Minimum value plus value, right? So I will return 8 plus 4, which is 12. So I will return 12 here. So by going left, I got 13. And from going straight, I got 12. And from going right, I have got 12. What is the minimum value? 12. So 12 plus what is the value here? 1. And 12 plus 1 is 13, right? So by considering 1 as an element, I got an minimum sum as 13 here. Okay. So what if I consider the element as third? If I consider the element as if I consider this element, and so if I consider this element, can I go to left? Yes, I can go to left, right? So I'll go to left here, and from left I can go to left, and I can go to right. I can go to straight, I can go to right. So if I go to left, it is a base condition, so I'll return 7 here. Okay, I have written 7. And if I go to straight from 5, if I go to 8, yes, 8 is also a base condition, so I'll just return the 8 value here. If I go to right, so 9 is also another base condition, so I'll return 9 here. Okay, from here among these three, what is the minimum value? 7 is the minimum value. 7 plus what is the value here? 7 plus 5. So 7 plus 5 will be 12 here. Okay, so 7 plus 5 is written. So from going left, I got a value of 12 here. Okay, what if I go to straight? What if I go straight here? So if I go straight here, what is the from here, where can I go? I can go left, I can go straight, and I cannot go right here. So if I go left, I will return 8. If I go straight, and what will I return? I will return 9 because it is a those are the base conditions. From right, I can return only max here. I cannot go to right. So what is the minimum value? 8 is the minimum value. From 8, by going straight, 8 is the minimum value. And what is the value here? 8 plus 4, and I will return 12 here. Okay, so by going straight, I got a minimum value of 12 here. Okay, what if I go to right here? So if I go to right, it is I cannot go to right, so I'll just return the maximum value. So among these three, what is the minimum value here? 12 is the minimum value. Okay, so 12 is the minimum value plus 3. What is the answer? 15. So by considering third element here, I got an minimum value of 15 here. Okay, so if I consider these three, now if I consider by considering one element, I got 14, and by considering second element as a first element, I got 13 and 15. By considering third element as a starting element. Okay, so what is the minimum here? So minimum is the minimum where I can get the minimum by considering one element as a minimum element. Okay, so what is the path here? So this can be the path, or so what is the path here? 12 and 12, right? So I can go straight. So what is the path here? So I can go straight here. So I can go here, or I can go left. Okay, I can go straight, or I can go right here. Okay, I can go here, and I can consider this thing. Okay, and I can come here. Okay, 8 plus 4 is 12, 12 plus 1 is 13, and 1 plus 5 is 6, 6 plus 7 is 13. So in this way, these are the parts of the solution. Okay, and this is the recursive tree we have we have visualized here. So if you what is the DP here? We need to store every value here, right? So if you observe one thing here, you are going to the this element, right? So 1 comma 0 you are going. Okay, so you are only performing these operations here. Okay, and only performing these operations. So what if I store all the elements here? Okay, so from by considering this thing, I can go left and I can go straight and I can go right, right? If I go left, I got an answer as 13 here, right? So I have all so by going left, that means 1 comma 0. By going straight, by going 1 comma 0, I got an answer as 13. And by going right, I got an 1 comma 1 as, by going right, that means at 1 comma 1 index I got an answer, minimum answer as 12. So if I consider the second element, so here if you observe, I've already calculated the answer for 1 comma 0, and we are again calculating the answer here. So in the DP approach, what we can do, we can store the answer for 1 comma 0, and we can try to minimize this execution tree, right? So we can directly return the value here, right? So here the value will be the same if you observe. So we are already calculated the answer for 1 comma 0. Why we need to again calculate the answer for 1 comma 0? So I'll create the for 1 comma 0 subtree. So uh, we can delete this tree, right, in DP. So we will execute try to store this, and we will try to ignore this. Okay, and we will try to delete this because we have already calculated for this node, right? We have already calculated for this node. So we are not again we are not calculating it again, right? So we have already calculated the answer for 1 comma 0 here. So we will try to store this answer in some another array, and we will try to, whenever we go to this, we will directly return from here. Okay, so I will just return the value, whatever the value, I will store it and I will just return to it. Okay, so if you go to straight here 1 comma 1, did I go to 1 comma 1? Yes, you can see here I have already calculated the answer for 1 comma 1, which is 12. So here the answer is 12, so I can just delete this, right? I cannot go again here. I will not go again here. So uh, I'll just try to store this answer for 1 comma 1, and I will just return from here. Whenever I go to 1 comma 1, I'll just try to return the answer here. So I will just delete this here. Okay, okay. So I've already calculated the answer for this thing, so I will not again try to calculate the answer for subtree of 1 comma 1. I'll just directly store the 1 comma 1 answer previously here, and I will whenever I visit it again, I will just return it here. So did I calculate the answer for 1 comma 2? So 1 comma 2 answer is not calculated, so I'll just calculate this answer for 1 comma 2. Okay, so when I try to zoom it here little bit. Okay, this is the visualization tree, right? Okay, this is the visualization tree. So I have not calculated the answer for 1 comma 2, so I'll go to the subtree of 1 comma 2, and I will just calculate the answer. Okay, so now if I consider the third element of our starting element, then what I should do here, I have to check whether I have calculated the left index or not. So 1 comma 1 is already calculated here, my friend. Here 1 comma 1 is already calculated, so I don't need to calculate it again. So I'll just try to store the 1 comma 1 value previously, and I will just return here whenever it appears. Okay, so I'll just return here. I'll just return the value of 1 comma 1. So here it is 1 comma 2 here. So now the answer will be 1 comma 2 here. So you have already calculated the answer for 1 comma 2 here, my friend. For if you consider the second element, you have already considered calculated the answer for 1 comma 2. You should have if you store the answer here in some other variable, then you don't need to calculate the answer for this. Don't need to calculate the subtree again, right? So I'll just have already calculated, so I'll just directly return here. So I'll just delete this thing, right? So I don't need to calculate the answer for this thing. Okay, so it is all 1 comma 3 is always max, so it cannot go. So if you observe now, what is the sub tree here? So you just need to calculate the answer for this subtree, right? So and you have to calculate the answer for this subtree, and remaining all we can just if you calculate those answer and store that answer in some variable, then if it comes again, then we can directly return that value, right? So this is the magic of DP here. So we have, see how much time complexity we have saved here, right? So how much time complexity we have saved here? Once observe here. So we are not at all calculating the subtree of 1 comma 1, 1 comma 2, 1 comma 3 here, because we have already calculated the answer for 1 comma 1, 1 comma 2, 1 comma 3 previously here. So we are just in previous section we were just storing the answer. Now we are just returning the answer, stored answer, right? This is the DP here. So this is the visualization of DP. So now we will let us code the DP approach for this problem here. So what we have to do here, we need to store the right. We have to take a DP uh, of 2D array here, 2D DP, because I and J are changing here, so right? I and J are changing here, right? Because I can be different value, J can be different value. So how we have to consider DP? So whatever the changing values you have in your parameters, like in your function, whatever the changing parameters you have, so that many you have to consider as a DP, right? So here the two parameters I have are changing here, so I have considered a 2D DP here. Okay, so now I have considered the 2D DP, and I and J are the indexes of matrix, right? So what is the maximum index of the matrix? So it will be n minus 1, right? So I will consider n plus 1 as my indexes of my as DP length, right? So DP length. So what I have to do here, I have to fill every element in the DP to maximum here, right? So a comma integer dot max. So now what I have to do, I have to pass the DP here, right? So I have to pass the DP here, and what I have to do, what I have to make the changes. Now I have to make it. So now what will be the edge case here? Now we have to check whether it is calculated previously or not. If DP of I comma j is not equal to integer dot max value, okay, if it is not equal to integer dot max value, then it is a different value. Then we can consider that it is already calculated, right? So we can directly return here DP of I comma j. So from this statement we can consider that it is already considered, right? It is already calculated. You don't need to again do the all the below thing here. You can directly return here, right? We have to check whether it is previously calculated or not. If it is calculated, then return here. If it is not, then perform the operations, whatever the below operations you have, perform those operations, right? So now what we have to do here, before returning that, we need to store it in a dp of I comma j here. So whenever you store it in a dp of I comma j, whenever you try to visit, try to come to that I comma j position once again, then you can directly return the position value there. Okay, here I am storing the position value. Here whenever I come to that position, I can directly return that position value. This is the dp approach, and we have to pass the parameters as dp here. Okay, this is the memorization of dp. Okay, so we will try to run this problem. Okay, and I need to okay, I need to even consider this. So function. So did you observe how simple is DP when you know the recursive approach here? So first of all, when we want to master DP, we have to master recursion here, right? Whenever we master recursion, then DP is a cakewalk, cakewalk way. Okay. So we'll try to submit here. It passed on MS, and this is the solution of a DP here. So how did we get the DP approach here? When we visualize the recursive tree, they are repetitions, right? There are repetitions of the positions, right? So if there are repetitions of positions, then if we try to store that positions, whatever the repeated positions, when we try to store that position, whenever we again go to that position, then directly we can return that position value, right? So this is the DP here. So there are repetitions in the recursive tree. Whenever there are repetitions in a recursive tree, then it can be solved in using DP approach, right? So then it can be solved using DP approach, right? So what will be the time complexity of this solution? So as it is going uh, to only n places, right? So as it is going to n places only. So if you observe from if you observe, first it is calculating only for n positions, right? So it is going, so from here it is going here, it is going here, it is going here. So it is trying, first it is trying to calculate every position, right? Every position's value it is trying to calculate. In DP approach, if it is trying to calculate for every position, so what will be the time complexity here? So the time complexity will be TC will be big O of n into n here. Okay, because n into n elements are there, right? So n is the matrix dot length, right? So how many elements are there? N into n elements. So it is trying to calculate for every element here, right? The DP approach is trying to calculate for every element, and it is so in the what will be the how much time it is taking, how much time it will take to calculate every element here? N into n, right? So this is the time complexity of the DP approach, and the recursive approach will be 3 to the power of n. It is an exponential, right? It is an exponential, right? So, and the space complexity will be, what will be the space complexity? And we are using an extra space here for storing the DP. So it will also be n into n. Okay, this is the solution here. If you want more type of this problems, then comment down below and let me know in the comments, so I can solve more this kind of problems. And thank you, and like the video and try to comment your things, and whatever you haven't understood here, try to comment down so that I will, whenever I read the comments, I will try to improve myself. And if you want any improvements in my explanation or something, then try to please let me know in the comments. And That's it. And subscribe to the channel, and also turn on the bell icon there, so that you can get a reminder whenever I upload a video. Okay. And if you want more type of these problems, and follow LeetCode and Sleep channel. And yeah, that's it. And thank you for watching.